Good morning, friends. What this video is going to be is a couple of problems on the test that I made up that you didn't get the solutions to. So the first one being, it might have been not problem number 2. This is from the original test, not the retest. I gave you this chart, and there were a couple problems that involved using this chart. And this chart was basically just a chart of f values, f prime values, g values, and g prime values. And then I asked you some questions. The first one being, I think this again was problem number 2. I gave you this function q of x, which was defined to be 2f of x over g of x, and then I asked you to find q prime of 2. You've had some problems like this in the homeworks from the book, but this is basically a quotient rule problem. Where you're just doing everything symbolically and there's no equation. So we're going to do the quotient rule here. I'm going to say that that's low, d high. Oh, by the way, I'm going to stop here. I'm going to erase this. And let's talk about that 2. Because this 2 could be dealt with in a variety of ways. The easiest way, I think, to deal with this 2 is when I go to take the derivative, I just put 2 times whatever the derivative of f over g is. Much easier to deal with, then you don't have to keep track of it. So now if I go low, d high, minus high, d low, over low squared. Okay? So that's the quotient rule, and now I just want g prime of, or I'm sorry, not g, it's q. When I want q prime of 2, which is right here, I'm just going to plug 2 in here. That's g of 2, f prime of 2, minus f of 2, times g prime of 2, all over g of 2 squared. And when I do this, g of 2 is 1, f prime of 2 is 4, f of 2 is 2, and g prime of 2 is 2. And when you do that arithmetic, you get 2 times 0 over, and it doesn't matter what's in the denominator, as long as it's not 0, which it's not. So q prime of 2 is equal to 0. Okay? So that was that first question. I'm going to erase this. We'll do the next. All right, here we go. Good morning. Back. Well, good back. We're back. Yeah, I don't know. Good morning. I already said good morning, I think. You're not even going to be watching this in the morning, so I don't even know that matters. Okay, so the next one was this one. It was the question right after the one we just did. I defined a new function for you, which was f of x times g of x plus 2x. And in this one I said, it was a two-stepper. It said find h prime of 3, and then also to find the equation of the tangent line at x equals 3, 2h. So in order to find h prime of 3, we got to find h prime of x. And you should write that expression down for h prime of x. So we got the product rule here, and then I've got just the derivative of 2x there. So here we go. Derivative of the first times the second plus the derivative of the second times the first. So that's the derivative of f times g, and then plus the derivative of 2x, which is just 2. So now when we find h prime of 3, that's going to be f prime of 3, g of 3, plus g prime of 3, f of 3, plus 2. So now I can just pick all these numbers off the chart. I should be able to pick them off a chart, I should be able to pick them off a graph, and I should be able to plug them into an equation. Okay? So f prime of 3, that's 2. G of 3 is 4. G prime of 3 is 3. And f of 3 is 1. So this is 8 plus 3 plus 2, which is 13. Okay? That's h prime of 3. So that's the slope of the tangent. Now we need to get the actual point of tangency. What is the coordinates of that point? So in order to do that, that's going to be the point 3 h of 3. And so I just got to figure out what h of 3 is. So h of 3 is going to equal f of 3 times g of 3 plus 2 times 3. So I go over here and I say f of 3, 1, g of 3, 4, plus 2 times 3 is 6. This is 10. So the equation of our tangent line is y equals 10 plus 13 times x minus 3. Done. Okay. These are the product rule and the product rule and the quotient rule, kind of symbolically, where you just have to manipulate things and execute the rule. I mean, these are actually a little easier to actually compute because there's just so much less algebra involved. But sometimes you can get hung up on these. So hopefully that makes sense. Okay, next one I want to do was this one, which asked you for the derivative of the function 2 sine squared of x. Okay, now when we actually took this test, you hadn't learned the chain rule yet. This problem could be done with the chain rule, and I'm going to show you how you can do it without the chain rule, but honestly, we'll probably do it with the chain rule when we actually do it. I thought I heard Mr. Alexander come on, but apparently he's not going to come on. If he does, I might pause it so you don't have to listen. But how you were supposed to do this without the chain rule was like this. Oh, well, I'm going to pause so you don't have to listen to him. It's terrible. Oh, sorry, we're back. Talking to Snyder about coffee.
Don't do it.
Yeah, so here we go. This is, so if I write this like this, then I would have just used the product rule. So I would say the derivative of the first times the second plus the derivative of the second times the first. In all honesty, like I'd say at this point in our lives, since we know the chain rule, let's just go ahead and do this with the chain rule. Of course, we're going to think of it like this. And so the derivative is going to equal 4 times sine of x to the first. Now you're wondering, where did that 4 come from? Because the 2 times 2. And then times the derivative of sine of x, cosine of x. Okay? So that was pretty easy. I feel like in one of the early on videos when we learned the product rule, I feel like I might have done this actually as an example. The next one I want to do, and I've got space to do it, was this one right here. Okay, it was the derivative of this function. Actually, I wrote it as this. Sorry, I think I wrote it like this. Instead of just taking the derivative, I said, what's f prime of x? So I defined it as f of x. Okay. Turns out this is a really easy problem. You could have found the derivative of this and found the derivative of this and then simplified it. The derivative of sine squared is pretty much right up here, except it's half of this, so it's 2 sine x cosine x. And the derivative of cosine squared is negative 2 sine x cosine x. It turns out, however, that sine squared plus cosine squared is equal to 1. So if I simplified this function before I did any calculus, I would have simplified it to 1, and then when I took the derivative, I'd get 0. Okay? So that's a little bit of a... Sometimes I like to sneak stuff like that in there just to make sure you're on your toes, thinking on your feet. But you didn't have to think on your feet. You could have just done this and simplified it and gotten 0. So, okay, there's one more I want to do for you, and so I got to erase the board, and we'll be right back. Okay, so here we go. This is the last one that I was going to work for you on the test. This is one of the ones I made up. I love this problem. Because you think that this is a limit problem, which, I mean, I guess it is a limit problem, but this is really a derivative problem. Because what I'm asking you for is I'm asking for the limit as h goes to 0 of the cosine of x plus h minus the cosine of x over h. Okay, that should smell familiar to you because that's the limit definition of derivative. The limit as h goes to 0 of f of x plus h minus f of x over h. We should recognize that. What function is being applied to this definition? It's cosine of x. So this answer, this problem is really just saying, hey, what's the derivative of cosine of x? I mean, this is actually equal to the derivative of cosine of x, which is just negative sine of x. Okay? You would have done that problem with no work, just recognizing that that's the definition of derivative. The one that was on the retest, I think, was the derivative of sine, which would have been cosine, if I remember right. It's a pretty easy problem if you recognize that it's the definition of derivative. Now, it turns out that if you actually try to compute this limit algebraically, it's pretty complex. We often, in many years, we will do this together as a class. It involves some fancy footwork with a limit, but I figured it would be one of those two things that would just be too confusing to try to work through virtually. So maybe when we come back, we'll work it out, but work it out algebraically. But we don't have to work it out algebraically if we just recognize that, hey, that's the definition of derivative. I know that. I just got to figure out which function is being derivatized, and it turns out it's cosine of x. So the answer, negative sine of x. So those are the ones from the test that I made up, that weren't Delta Math made up. So there's the answers. If you have any questions, let me know. We'll see you.